Hello, I'm Mrs. J, and we're going to work on Module 10 and 11 in ALEX, and this one is the sum, difference, product, or quotient of two functions. So looking at this one, g of x is 4x minus 4, and h of x is x plus 5. They want us to find h minus g of x. Well, that just means to subtract them. Take h of x and subtract g of x. h x plus 5 minus, now what you need to be careful, this negative has to distribute to all of this one. And then combine like terms. And that's your answer. This one, and sometimes they don't have the dot there. They could just have hg of x, but that just means to multiply the two. So if we take h and multiply it by the 4x minus 4, and we get 4x squared minus 4x plus 5 times 4. (20x minus 20). So we have 4x squared minus, plus 16. I just want to double check. The last one, they're giving us a number to plug in. Now you could plug the number into both of them first and then multiply them, or you can find it first and then plug in the one. Either one. And you wouldn't multiply though. This one wants you to add them. So h is x plus 5 and 4x minus 4. Combining, we have 5x plus 1, and then plug the 1 in from here. So you could do it that way, or you could find each of them first. H of 1 plus g of 1. H of 1 plus 5 is 6. G of 1, 4 minus 4 is 0. 6 plus 0 is 6. So those aren't too bad. The quotient ones, now when you're doing these ones, notice they're dividing and putting a number in, but then they want us to find the domain. So find it for x first. Kind of do this one backwards. Find the domain first and then do a. Make sure we have it written right. Okay. So we want g over h. Right now we know these are both all real numbers because there's no fractions, there's no square roots. We know x is a member of all real numbers. So both of these will be all real numbers. Now to divide them, g is on top. Divided by and this would be your answer. Now for the domain, Since nothing's omitted here, we only see what we omit from this one, which is the denominator cannot equal 0. Add the x to the other side. -5 has to be omitted from the domain. And then they gave us I don't know why that keeps doing that. -3. So you plug in a -3. -2 minus 3, 4 minus 3 over -5 minus a -3. -5 times 1 over negative positive -2. 5 halves. Let's try one more. -5 plus 2x squared g 7 minus 9x h over g. -5 plus 2x squared over 7 minus 9x. So to find the domain, we take the denominator. It cannot equal 0. -9x cannot equal -7. Divide by the -9. So we need to omit a -7/9. Well, negative and negative is a positive 7/9. And then plug the value in, -1. So -3 on the top, 9 and 7, 16 on the bottom, -3/16. The advanced is not very much different. Oh yeah, it is. It has fractions. Quotient. There it is. Okay. So f of x equals 9 over x plus 7, and g of x equals x over x minus 2. And we want to find g over f, or g divided by f, and then state the domain. So if we look at this one, setting x plus 7 cannot equal 0. We know x cannot equal a -7. Subtract the 7 to the other side. And this one, x cannot equal 2. So right now we have these two omitted from the domain. And we have g x over x minus 2 divided by 9 over x plus 7. When you have a fraction that you're dividing by, you can flip it and multiply. So this is the same as x over x minus 2 times, and then flip this, x plus 7 over 9. So we have x times x plus 7 over 9 times x minus 2. And this would be your answer. For the domain, we have -7 and 2. And there's nothing new in the denominator. If this x were down there, we'd also have to omit 0. But since it's not there, we only have these two. So the domain's -infinity to -7, -7 to 2, and 2 to infinity. Let's try another one. Okay. F of x equals x minus 5, and g of x equals 6 over x. So this one's all real numbers. This one, setting the denominator equal to 0, x cannot equal 0. And then we're taking g divided by f of x. So we have 6 over x divided by x minus 5. When you have something that's not a fraction, you can place it over 1, and then we can flip the bottom and multiply. 6 over x times 1 over x minus 5. 6 over x times x minus 5. So that would be our answer. For the domain, we know x cannot equal 0 here. This one was all real numbers, so we don't need to worry about it. This one was 0, so we can't have 0. And setting this one equal to 0, it can also not equal 5. So we have -infinity to 0, 0 to 5, and 5 to infinity, and you should use a u to combine them. And that's all that's to those.